suspect many of you in the audience are thinking about the Wuhan coronavirus today. I'm not going to be talking about Wuhan very much, but I'm going to talk about another deadly virus, and much more deadly, actually, the Ebola virus. The Ebola virus has death rates of up to even 90%, and there's a current outbreak going on in the Democratic Republic of Congo since 2018, which continues to this day, and has had a case fatality rate of about 65%. One of the big challenges with Ebola is trying to get diagnostic tests to the people. It's very key to have good diagnosis in order to limit the outbreak. And so this is a significant challenge for recognizing and controlling an outbreak. Many of you probably remember in 2014, Ebola first came to the United States, and I had been working on Ebola for about a decade before this, but you may remember this famous picture of the first patient in the U.S., Dr. Brantley, coming off out of the ambulance at Emory University Hospital. This is where I got my experience working at the U.S. Army Medical Research Institute of Infectious Diseases, and or USAMRIID. You've already heard about this. And this is the largest bioweapon defense institute in the world. So I had the opportunity actually running the Division of Medicine in 2004, and we had a very serious exposure in the laboratory with one of our scientists who sustained a needle stick while working with Ebola. And so I got very interested in this in terms of understanding the risk in the laboratory for exposure, understanding how do we manage patients appropriately with the right containment such that they don't infect their care providers. And then later I was able, while working in the virology division, to work with Ebola in animals to try to figure out how does this infection actually impact the human body, and then how do we actually treat people appropriately. So unfortunately, as you may see here, you can see a lot of crosses in the environment here in sub-Saharan Africa, and this is a very sad testament to the way these outbreaks actually decimate populations in that kind of environment. Now, one of the challenges is the delay in diagnosis because it costs lives. It takes about 5 days on average for the patients to go from when they have their onset of symptoms till they're actually into the care environment. And if we could actually diagnose an outbreak earlier, diagnose patients earlier, and get them actually in for care, then we can limit the spread of the virus. In addition, ultimately, we could save lives. This is what the enemy looks like. It's a filovirus. This is the Ebola virus under electron microscope. The term filovirus comes from the Latin phylum for thread. You can see this filamentous form, why it gets that name. The first outbreak of Ebola virus was 1976 in the Democratic Republic of the Congo, also known as the DRC. And as you can see from the map here, the Ebola River is near where this first outbreak occurred in the Congo, and that's hence the reason for the name Ebola. So we've had 44 years of Ebola. And most of the outbreaks occur in sub-Saharan Africa, but also we had a very large outbreak not too long ago in West Africa. Now, what we think happens in the wild is that fruit bats that circulate in the forest canopies are the reservoir host for the virus, and they secrete the virus in their various different secretions. And at some point, there's a spillover event which goes to either non-human primates, such as the monkeys or gorillas, or potentially small antelopes. And humans then get infected when they have direct contact with one of these animals, often when they find some bushmeat in the forest and they eat the bushmeat, they become infected that way, or if they have direct contact with the bats. And then this person then starts the outbreak. As they become ill, they're cared for by their family members, or they go to the hospital, and they can spread the illness to those direct contact individuals. Or when there's a funeral, you can actually have large amount of spread because a single individual who's died has still a lot of virus on them. And they're in the cultural practices in some of the countries in sub-Saharan Africa, there's a lot of direct contact with the dead body. And so you can have whole villages infected at the same time. What happens is individuals will be infected, and then they have what's called an incubation period before they become ill. And at the time they have onset of infection is when they become contagious. Now, initially, they may just have what feels like the flu, a fever, chills, muscle aches, headache, and then over the next couple days, they start progressing to what we call a wet illness. They start having vomiting, diarrhea, and near the end of the first week, they can start getting real ill where they're having even more vomiting, diarrhea. We're talking liters and liters of fluid, and these body fluids are filled with virus, and the concentration of virus increases exponentially as the illness gets worse. And so by the time they come to the point where they're severely ill, they can bleed or have lots of fluids that are contaminated with virus. Now, we had some recent good news with Ebola. There was a study done with 4 different drugs in the DRC in this current outbreak, and they found they could take the death rate of 65% and cut it in half overall average for the patients with 2 of the drugs. And if patients could get in early with the lower virus levels and less ill, they actually could knock the death rate down to 10 to 12%, which is really pretty amazing. For someone like me who's watching this over the last 2 decades, to see something that's 90% fatal down to 10% was really quite amazing. And this is a great opportunity. The challenge is getting people in early to get that treatment. So there's lots of reasons for this delay. There's mistrust of the government in some places. There's mistrust of the medical establishment and very limited medical and public health infrastructure. And part of the reason for this mistrust of the medical system is that patients will go into the hospital. It's much like the Hotel California. They can check in, but they don't check out. And so the people in the villages see this, and they're very disheartened, and they're afraid to bring their family members to the hospital. And so they'll keep the family members at home. The downside of that is, as the patients become more ill, they put themselves at risk. So if we can get them early in and get them care and get them out of the family home, we can reduce the spread. There's also, in some of these environments, just the logistics of transport and limited electricity prevents us from doing a lot of things. If you don't have electricity, you can't refrigerate patient samples, you can't refrigerate diagnostic tests or some of the treatments. So I recently had the opportunity to actually see some of this firsthand, going to the field environment. So you can see the DRC here in the center. I went to the smaller country of Burundi, which is just to the east, and my job there, working for the World Health Organization, was try to limit the spread of the disease if it came across the border into Burundi. And so here I am. I did assessments of 10 hospitals while I was there. I did an assessment of their Ebola treatment unit to try to prepare in case this did spread across the border. Now, as you can see, in some areas in this country, it's quite an impoverished environment. These are some of the houses you'll see along the road. And then you see the transportation's pretty difficult in some of these areas with a lot of mud on the road. And it took me about to go 40 kilometers, it took me about 4 hours in going to one part of the country. And then even when the roads are good, you can see there's a lot of obstructions in the road. On the left, you'll see cattle there. On the right, you'll see lots of vehicles, and you'll see people with bicycles with just about everything you can imagine being carried on the back of the bicycles. And there's also periodic roadblocks caused by the police stops. So one of the possible solutions we've thought about is trying to get the diagnostic tests for Ebola out to where the people are. So I have some colleagues who have also got similar background working in the field environment, doing science and logistics in this environment. And we decided to put together a company called Integrum Scientifics. And we have the vision of trying to reduce the impact of pandemic threats, especially in the most vulnerable regions in the world, in places like sub-Saharan Africa. And we got our heads together, and we developed a prototype next-generation mobile laboratory. It's basically a laboratory on the back of a truck. And the key thing is to be able to maneuver in this environment. So it's got 4x4 wheel base. It's got a high wheelbase for being ruggedized in this type of environment. It has winches on the front and the back, so when you do get stuck in the mud, you can actually pull yourself out. It's got, it runs on dirty diesel, which is what's available in some more remote environments. The back of the vehicle is collapsible So it can go into a C-130 transport plane. These are large planes that don't require a very long runway, so that you can get them into the more remote areas, and then essentially drive the vehicle off, pop up the top, and you're ready to go. You also have 2 different generators on the vehicle to try to generate electricity, as well as a battery backup. So this is a colleague of mine demonstrating the vehicle interior. This is our prototype we brought to the International Tropical Medicine meeting last fall to showcase the vehicle for the first time, and he's demonstrating the vehicle to some high-profile visitors. And we can outfit this vehicle with all sorts of different diagnostic platforms. So what could we do alternatively? Well, we could use the status quo, which is the same problem we have right now with delays. We could build fixed facilities, but that costs millions of dollars potentially, and then you're still stuck not getting out to where the patients are in the remote environments. Or you can use small suitcase-sized laboratory equipment and take them out to the remote villages, but then you lack the infrastructure of the electricity and refrigeration capabilities that we can bring with this vehicle. So the bottom line is, we think we can do better now with Ebola. A mobile laboratory is potentially one solution that might help. And I will say, we've also been discussing whether this capability could be utilized in the current outbreak or other outbreaks to get this vehicle out to the field environment and bring it to where the patients are. Thank you.